Hi everyone. Today we're going to start our chemistry unit and we're going to begin by talking about something called elements. If you need to get a hold of me or if you have questions, the best way to get a hold of me is via my email, which is shown on the screen. So let's go ahead and get started. So elements are what I would call the simplest substances. And when I say the simplest substances, really what I mean is they're substances that cannot be broken apart into more simple substances. So for example, some of you have heard water called H2O before. Uh, the H in H2O stands for hydrogen, and the O stands for oxygen. So water is not an element. It is made of both hydrogen and oxygen. Both of those substances, by the way, are elements. So if we look at something like gold, gold is an element. It is made of only gold. So the key bit for you to understand today is that elements are the simplest substances. They can't be broken down further. So when we look at elements, and this is something that's true mostly of all pure substances, elements have a unique set of properties. And a property is just really it's anything that describes the way a substance looks or the way a substance behaves. So let's look at this copper pot, for example. So this copper pot is made of copper. So when we say what are the properties of copper, we might say that it is copper in color. We might notice that this has been hammered. We can see the little hammer marks on it. So it's soft. Copper is soft. It can be shaped. Copper is also shiny. It reflects light. Copper is a good conductor of heat and of electricity. That's why we use copper in both wires for electricity and why it's being used for this pot. We can see that copper is a solid at room temperature. So at temperatures that we might find average here on Earth, it's a solid. It's also very heavy, which means it has a high density, and it smells or tastes a little metallic or bitter. So those are all properties of copper. And so every element has its own unique set of properties. None of the elements have properties that are exactly the same as any other element. One way to look at these elements is I want you to think of them as building blocks. And these are building blocks that make up everything around us. So a key vocabulary word, and this is a word some of you have run into in other other classes and in other ways, is something called composition. So composition really is just a list of what something is made from. So when we say building blocks, another way to think of building blocks is ingredients. So let's take a look at this picture. You are something, and so what's the composition of a human being? So if we look at your composition, it's easy to say, oh, I'm made of muscle and bone and all kinds of tissues, and you might describe the human body organ systems. But when it comes right down to it, your composition is of these elements. So about 65% of you is oxygen. About 18.5% of you is it's an element called carbon. About 9% of you is an element called hydrogen. And about 3% of you is an element called nitrogen. And then this little bitty bit up top, that represents trace amounts of other elements. Okay? So composition is just the list of substances something is made from. And I want you to know that everything around you, including you, is made of these elements. So when we talk about elements, it's impossible not to talk about something called the periodic table. And on screen, this is an example of the periodic table. At first, I know this looks a little overwhelming because this is a lot of information, and that is true. We're going to take several times to look at the periodic table. And really the periodic table is just a chart that's going to show all of the elements that mankind knows about. It's all the elements that we know to exist. And so we can see on this chart, this is really almost like a list. There's going to be some very familiar substances. As you read through a periodic table, you're going to see some things you say, oh, I've heard of that before. And so the periodic table is where we go if we want a chart that lists all the elements. But there is much, much more to the periodic table. We'll continue to look at the periodic table. So one of the things that we're going to find on the periodic table is we're going to find that you have these blocks. Each element has a block, okay? So it has its own square. And at the top of that block, most often, is something called the atomic number. We also are going to have something called a chemical symbol. and we're going to have something called atomic mass. So let's take a look at the chemical symbol first. So the chemical symbol is going to be a short abbreviation for each element. Let's go back and take a look at that. So I'm going to start up here in the top corner. So here we can see, up here's our atomic number, right? That was up at the top, and that's a whole number. But here is our chemical symbol. So the chemical symbol, this abbreviation for hydrogen, it's going to be just the H. So the capital letter H is the abbreviation or the chemical symbol for hydrogen. If we move across, here's atomic number 2. Here's helium. The chemical symbol for helium is going to be He. We look down at element number 6, carbon. Its atomic symbol or its chemical symbol is going to be a capital C. Okay, so the chemical symbols are just really a shorthand way that prevent us from having to do a whole lot of writing. As we move on, that's going to become more and more important, particularly as we start combining these elements to form new substances. So, some rules about symbols. The permanent chemical symbols always have 1 or 2 letters. Now, on the periodic table, you may see some elements that have 3 letters listed in their chemical symbol. Well, that just means that that's not their permanent name yet. They don't have a permanent name, and so that's just a temporary symbol. So we can ignore those. Please bear in mind, the first letter of a chemical symbol is always capitalized. And some of the chemical symbols, as you're going to notice, are taken from older names, and so they're going to look strange. So let me look at find iron, Fe. So clearly carbon begins with a C, so a capital C makes sense. But if we look at iron, here we have an Fe. Well, that doesn't seem to make any sense. So really, this element, iron, has been known for a very long time. And so this chemical symbol is actually based off of a much older name. I think it was called barium or something like that. But some of the symbols make a lot of sense, others don't. So we can look at some here that don't. We can see gold is AU, silver is AG. That would seem rather strange. Here is lead, which is PB. So lots of these things that have been known for a bit, they're going to have strange chemical symbols. And the last thing I want to point out is I want to look on your periodic table. I want you to notice that everything has an atomic number. And really what this is for now just a unique number for each element. Now, so remember, when we look for an atomic number, we're going to be looking for something without a decimal. Because notice there's 2 sets of numbers in here. Here's a set of numbers. This is our atomic number here for hydrogen, it's 1. But down here is something else. This is another number, but this is something called atomic mass. We'll talk about that more later. If we move over here to aluminum, aluminum's atomic number is 13. Notice that's a whole number. If I move down to francium, francium's atomic number is 87. Notice that is on this periodic table, that is always going to be in the top left corner. Generally speaking, this stuff can move around on periodic tables depending on which periodic table you're looking at. So remember, your atomic number is going to be a whole number. And something else you might notice is our atomic number begins at 1 and it counts across in rows 2, 3, 4, 5, 6, 7, 8, 9, 10. And so if we were to follow this all the way through, and we'll talk more about why this looks like this down here, we're going to find that there are 118 total elements on our periodic table. So, atomic number. Our atomic number is going to be the unique number, always a whole number, most often found above our chemical symbol. And so guys, that'll about do it for today. And we'll come back and talk more about elements in the periodic table.